Welcome, and today we'll be talking about the TV-100 ventilator. The TV-100 is Bio-Med Devices' new industry-leading ventilator that offers the latest technology and provides the modes and performance of a full-size ICU ventilator in a compact design that is ideal for transport. The TV-100 stands at 12.8 inches. Its width is 11.9 inches, depth 7.6 inches, and its weight is 15.6 pounds, which is about as heavy as a gallon of paint. On the front of the ventilator, we have the patient output connector, flow sensor connector, exhalation valve connector, and the airway pressure connector. On the bottom right, we have the power button and the alarm silence button. This bulb located here is the battery charge indicator. Rapid blinking of the battery charge indicator LED indicates a problem charging and should put the ventilator out of service. On the left hand of the ventilator is the battery door. Turn the screw counterclockwise to open this door. Behind this door, we will find two removable batteries. Battery 1 is located on the left and battery 2 is on the right. To remove the batteries, slide the metal piece to either direction and then pull the tab on the edge of the battery. The TV-100 is capable of approximately 7 hours of operation with fully charged batteries under typical patient parameters. When running with two batteries installed, approximately 20 minutes of operation will remain after the second low battery alarm is triggered. An alarm LED indicator is located here, but we'll go over alarms later in this video. This black box is the AC adapter and can be unplugged here. Our ventilators come equipped with stretcher hooks. Some providers used to use their ventilators at the head of the stretcher. However, because of the TV-100's height, we are unable to do this. If you recall, in our balloon pump and stroke rescue protocols, it requires that the head of the stretcher be elevated 30 degrees and 15 degrees, respectively. These hooks easily and safely hook onto the railings for both our standard and XPS stretchers. Here is the external power connector. Just underneath it is the USB/software update connector. And here are two air inlets, and lastly, an O2 connector. Unlike the HT70, each circuit comes with a flow sensor, also known as a pneumotac. The placement of this flow sensor can be seen in this diagram. The vent can be used without a pneumotac, but the following information will not be displayed. Patient's measured exhaled tidal volume or minute volume, the volume or flow waveforms, neither of the loops, volume/pressure or flow/volume. Each circuit will be sealed and contain a flow sensor, a heat and moisture exchange filter, also known as an HME, and two inline bacterial viral filters. Inside the sealed bag, you can also find this sheet. In the top right corner, you will notice a reference number. Our circuit's reference number is 80018. This will be brought up later in this video when we are setting up the ventilator. When setting up your circuit, place the flow sensor on the Y piece end. Be sure that the flow sensor is facing up. Next, place the HME filter on top of the flow sensor. After this, place the inline filter at the end of the expiratory limb. Notice that we do not pull the exhalation valve off the circuit and place the filter in between the expiratory limb and the exhalation valve like we did with the HT70. Lastly, let's put the inline filter at the end of the inspiratory limb. To properly attach your circuit to the ventilator, place the tubing to its appropriate connector. The order to this does not matter, just that it is placed tightly and to the right connector. Each tubing has its own size and won't allow you to place a tubing on the wrong connector. For our purpose today, we are going to start from the middle and work our way outward. Grab the airway pressure line located on the expiratory limb just before the Y piece. Next, we are going to grab the exhalation valve tubing located on the end of the exhalation valve located here. Notice that this tubing is slightly smaller in diameter compared to the airway pressure line. Grab the end of the flow sensor. Located at the bottom of the Y piece is the flow sensor. The flow sensor has two small tubings coming out of it. One will be striped blue and the other will be clear. Follow the two tubes until you get to the end piece and plug it into the flow sensor connector. Lastly, grab the end of your circuit and connect it to the patient output connector. Now your circuit is properly connected to the TV-100 ventilator. Press the power button for a few seconds until the ventilator powers on. At power on, the TV-100 will perform a power on self-test. The power on self-test checks all microprocessors, all pressure and flow sensors, all valves, and memory. If the power on self-test fails, the TV-100 will display a warning pop-up with alarm message. At the startup screen, choose Adult for our patient type. Just underneath this, we can choose our circuit type. On the left-hand side, we have the disposable circuits, and on the right-hand side, we have the reusable circuits. If you recall, we are currently using the Bio-Med 80018 adult circuit. The compliance factor of the Bio-Med device circuits will automatically be entered when the circuit is selected, unless we are not using a Bio-Med circuit. Then we need to select Other underneath the reusable circuits. The user should then proceed to the Tools menu and perform a leak test, followed by a compliance test. Your selected parameter will be outlined red and have a light blue to dark blue gradient as seen in this image. Now that we have chosen our circuit and type of patient, we can now begin to set up our vent settings. On the bottom, we can either choose Continue or Setup Assistant. Continue will recover your last parameters and settings if your ventilator were to turn off for any reason. Setup Assistant will give you a step-by-step guidance to placing a patient on the TV-100 for the first time. Let's walk through the Setup Assistant. Here we have the Basic Setup and Advanced Setup. Basic Setup allows the user to set general parameters for quick ventilation of a patient. This will automatically calculate a set tidal volume of 7 milliliters per kilogram using the ideal body weight formula and sex of the patient. Because we need an order from a physician in order to make and change ventilator parameters, we will not be using this setup at this time. Instead, we will use Advanced Setup. For the Advanced Setup, rather than having all the parameters and settings displayed on the screen for the user to set, the Advanced Setup will present each parameter, starting with the mode, for the user to set. The user can accept a displayed value by choosing Next, or change each value by selecting the parameter. You can either use the arrow keys or type the number with the keypad to change the parameter. Some parameters allow you to set the alarms as you set up your parameters. We will cover setting our alarms a little later in this video. Notice that any change over 30% will display a warning. Simply hit yes when asked if you want to continue. Previously, with our other ventilators, we had an air-oxygen mixer located on the side of the ventilator, and it was used to set our fraction of inspired oxygen, or FiO2. The TV-100 has an internal blender, and we can set our FiO2 by changing our percentage of oxygen as seen here. Now that we're using a flow sensor, we are able to use certain instruments like flow cycling. With flow cycled ventilation, the ventilator cycles into the expiratory phase once the flow has decreased to a predetermined value during inspiration. The flow cycling variable can be fixed flow value in liters per minute or a percentage fraction of the peak flow rate achieved during inspiration. With the TV-100, this variable will be a fixed flow value in liters per minute. Flow cycled ventilation has many advantages. It is more comfortable for the patient by preventing frustrated expiratory efforts. If the patient needs to terminate a breath and exhale, the inspiratory flow ceases and the ventilator cycles to expiration rapidly. With conventional settings, the inspiratory time is rarely uncomfortable and prolonged. This is the main advantage of this method. It is also limited by changes in lung compliance and airway resistance, which could theoretically prevent inadvertent ventilator-induced lung injury. There are also some disadvantages. Tidal volumes may be poor in patients with poor lung compliance, resulting in inadequate minute volume. There's also problems with patient comfort, depending on the intelligence settings. Inappropriately low and inappropriately high settings could result in uncomfortably deep and prolonged inspiration or double triggering due to insufficient inspiratory time and tidal volume. Since we are using an artificial lung and will not be able to mimic flow, we will turn this setting off. The TV-100 also has a sigh breath setting. The ventilator can be programmed to deliver an occasional sigh with a larger tidal volume. This prevents collapse of the alveoli, or atelectasis, which can result from the patient constantly inspiring the same volume of gas. When using volume control, a sigh breath will deliver 30% more volume than a previously delivered breath. The inspiratory phase of the sigh breath is limited to 3 seconds, or the peak airway pressure high alarm limit, or the maximum allowed volume for the set patient type. These limits may result in the TV-100 delivering a sigh breath with less than 30% increase in volume. When using pressure control, a sigh breath will deliver an additional 10 centimeters of water pressure above the peak pressure of the previous breath. The TV-100 will limit this pressure to the high pressure alarm limit. Sigh breaths are delivered as follows. The first breath after sigh is activated will be a sigh breath. Subsequent sigh breaths will be delivered every 50 breaths, regardless of the breath type, or every 7 minutes, whichever comes first. Pressure trigger and flow trigger were covered in our previous video. Please refer to that video if you have any questions on that matter. Essentially, these parameters are like a wall. The higher the value, the higher the wall, and the more inspiratory effort is needed by the patient in order to trigger a ventilatory assisted breath. Set these parameters as prescribed by the physician. Now that your parameters are all set, press the continue button in the bottom left corner, then hit the start and stop ventilation button in the bottom right corner. Then finally press the start ventilation. This should begin ventilating your patient. At the moment, the TV-100 has 8 different modes. Volume assist control, volume synchronized intermittent mandatory ventilation, pressure regulated volume control assist control, pressure assist control, pressure synchronized intermittent mandatory ventilation, non-invasive ventilation, high flow nasal cannula, and lastly, continuous positive airway pressure for an intubated patient. As we already know, in SIMV mode, the TV-100 will deliver manual, mandatory, assisted, or spontaneous breaths. The clinician will choose between volume control or pressure control for these different types of breaths. The assisted breath period represents the minimum time between assisted breaths and will be determined by the set rate. In SIMV mode, the clinician is able to set the rate, eye time, PEEP level, and trigger sensitivities. Apnea detection is required in this mode. When pressure support is enabled, the ventilator will deliver flow sufficient to produce the set inspiratory rise time and establish the set pressure support level above PEEP. When the airway pressure reaches the set pressure support level, the exhalation valve will open. Ultimately, this will improve patient ventilator synchrony and decrease the work of breathing, specifically inspiratory muscle effort. Here we have a volume control waveform. In PRVC mode, we can see the parameters available are the same as what we would see in the volume assist control mode. So here's PRVC. The very first breath ever delivered by PRVC is actually a volume controlled breath. So you can see here that the flow is completely constant, affirming that this is a volume controlled breath. So the volume will increase up until this point, which is our desired volume of 400 milliliters. Once we have reached 400 milliliters, the computer does an automatic inspiratory hold. This is to determine the plateau pressure, essentially to figure out the lung compliance. Every subsequent breath from now on will be a pressure-controlled breath. So the pressure of the second breath will be the plateau pressure from the first breath. And as a result, we'll measure the volume achieved at this point. Now at this point here, the computer is figuring out if the volume achieved here is below or above our goal of 400 milliliters. Now the pressure of the following breath will be determined based off of the volume of this previous breath. Going back to our previous statement, every breath is calculated pressure based on the delivered volume of the previous breath. So let's use some numbers in this example. Here is the plateau pressure, and here is our desired volume of 400 milliliters. The very first breath it achieves 400 milliliters, and the result in our inspiratory hold is done, and the plateau pressure is determined to be 22 centimeters of water pressure. The very next breath and every breath afterwards will be a pressure-controlled breath. So first, 22 centimeters of water pressure is delivered in this pressure-controlled breath, and as a result, we only get 390 milliliters of air. Now remember, every breath is calculated pressure is delivered based off of the volumes of the previous breath. So you can imagine, since we're below our goal of 400 milliliters of air, the very next breath, the pressure will increase in order to compensate for the decrease in volume. So here we have 404 milliliters. Now you can see every breath, the pressure may change based off of the volume of the previous breath. So at the compliance or resistance changes with time, as will the pressure that is delivered. Assist control mode provides controlled or assisted controlled ventilation. If the patient triggers inspiration, the TV-100 senses the negative pressure or flow created by the inspiratory effort and initiates an assisted breath. If the patient fails to trigger inspiration, the TV-100 provides controlled breaths as determined by the clinician. The current mode selected is using pressure control. The TV-100 delivers flow as needed to maintain the set pressure for the duration of the inspiratory phase. The set pressure will be referenced to PEEP. This figure illustrates a TV-100 pressure control waveform, as well as a patient-triggered breath, designated with the P below it. The eye rise time is an index and does not have dimensions. For a specific eye rise time of 9 will be 2/3 of the total eye time. Eye rise time of 1 will be the fastest rise time, i.e. the highest flow that the TV-100 can deliver. The intervening range will divide the eye rise time into equal increments. In Pressure-SIMV mode, the parameters are the same as Volume-SIMV mode, except for the use of pressure control and eye rise time. NIV stands for non-invasive ventilation. In NIV mode, the TV-100 allows the clinician to set the IPAP divided by EPAP levels to be applied to spontaneous breaths. IPAP and EPAP stands for inspiratory positive airway pressure and expiratory positive airway pressure, respectively. IPAP is referenced to 0 and not to EPAP divided by PEEP, like with the Newport HT70. The clinician can provide CPAP in non-invasive modes by setting the IPAP and EPAP values to the same level. When providing CPAP in this mode, the rate should be set to 30 breaths per minute or 60 breaths per minute so that the ventilator updates the CPAP value every 2 seconds or 1 second, respectively. If the apnea delay interval is exceeded due to a rate set lower than the apnea delay time and there is no patient-triggered breath during that time, then the TV-100 will detect apnea. The TV-100 will ventilate per the configured apnea backup settings, and the apnea alarm will actuate. The apnea backup feature can be disabled by turning off the backup rate. In high-flow nasal cannula mode, there are only 2 variables you can change. The flow, which is in liters per minute, and FiO2, shown as oxygen percentage on the screen. If the system does not have oxygen inside it, the oxygen box will be grayed out, and you will not be able to adjust the FiO2. Lastly, the CPAP mode is for intubated patients only. While selecting the CPAP mode, you will be given 2 options: volume or pressure backup. These controls are used if the apnea delay time has elapsed and manual breaths are required. Depending on which backup was selected will determine whether or not pressure or volume will be given as a manual breath. In this mode, the TV-100 delivers a minimum continuous pressure during ventilations as well as manual or spontaneous breaths. If pressure support is enabled, pressure support breaths will be triggered by the patient's inspiratory effort via flow or pressure triggers. Pressure support breaths are triggered by the flow sensor, or if there is no flow sensor present, via the airway pressure line. Like with our previous ventilators, the training department has made a ventilator cheat sheet. These cheat sheets can be found under the Documents section on our iPads and underneath this video. When setting up the alarms, we will be following the operator's manual recommendations for alarm settings. These values will be found on the cheat sheet as well. Starting from the left and working our way to the right, we will set our patient's rate alarm. This should be 40% above and below the set rate. Your oxygen alarm should be set for 20% above and below your set FiO2. For PEEP, CPAP, IPAP, and EPAP, the high should be 3 centimeters of water pressure higher and lower than your set value. Your VTE, or exhaled tidal volume alarm, should be set 50% above and below your average exhaled tidal volume. Your MVE, or exhaled minute volume alarm, will also be set for 50% above and below your average minute volume. Your peak pressure alarm will be 10 centimeters of water pressure above and below PIP, or peak inspiratory pressure. Lastly, your mean pressure alarm will be 40% above and below your mean pressure. The Alarm Auto Set button is located at the top of the Alarms page. The Alarm Auto Set button is only available during ventilation. During standby mode, the Alarm Auto Set button will be inactive and will be displayed in gray. The Alarm Auto Set button is only available when the TV-100 achieves set parameters and the breathing pattern is determined to be stable. The TV-100 determines the breathing pattern is stable by detecting if there are no large changes in pressure or volume levels over a period of delivered breaths. When you press the Set button, the TV-100 will begin to set the alarms. The TV-100 will take 5 sample breaths, then calculate the necessary values to balance the alarm limits. The TV-100 will calculate the following parameters for the Alarm Auto Set. When an alarm condition occurs, the TV-100 will blink the alarm parameter that is out of limit on the alarms page. The physical alarm button will blink, and the TV-100 will sound an audible alarm. When you press the alarm button, the TV-100 will silence the alarm for 120 seconds. If you press the alarm button again during the 120 seconds period, it will cancel the alarm silence. During the alarm silence period, there will be no audible indication of the alarm condition. All visual alarm indications will function as normal during alarm silence. Alarm silence will be canceled if a new alarm condition occurs during the 120-second alarm silence period. In the top right corner is the event log. The event log page displays up to 32 of the most recent ventilator events, as well as the elapsed time since the event occurred. The Clear All button will clear the list of events. The alarms can be broken down into 2 types, medium and high priority alarms. High priority alarm conditions occur when a mechanical, electrical, or software failure may render the TV-100 inoperable. High priority alarms are indicated by flashing the alarm button red at a frequency of 2.0 Hz and will make this noise. Medium priority alarms signal a condition that requires immediate attention from the user. Medium priority alarms are indicated by flashing the alarm button red at a frequency of 0.5 Hz and will make this noise. Under the Lung Mechanics tab, you will find an animated lung which represents the patient's lung movement. The lung expands as the patient's lung volume increases and contracts while the patient's lung volume decreases. The trachea is used to animate the direction of airflow in the lung. A blue arrow pointing downwards appears on the trachea when the air is flowing into the patient's lungs. A blue arrow pointing upwards appears on the trachea when an air is flowing out of the patient's lung. By going to the Lung Mechanics tab and pushing the inspiratory hold button located in the bottom left corner, you can determine the patient's static compliance and plateau pressure. By pressing the expiratory hold button, the user is able to determine the Auto-PEEP. If you have any questions or concerns, please reach out to any of the training staff. Thanks for watching.